Welcome to my first video on polynomials. In this video we're going to be just getting into the basics of polynomials and specifically into a whole bunch of definitions that are important to know. Before we actually define what a polynomial is, let's start by doing a few review terms that are important to know. Alright, let's start off with variable. Now, I'm sure by grade 9 you've heard of this term before, but just to make sure we're all on the same page, a variable is a letter, usually a letter, representing an unknown value or unknown number. The most common variables that are used are x, y, and sometimes z. The next important term is a coefficient. And that is the number that's being multiplied by the variable. And I'll give you a couple examples in a second just to clarify this. And the third review term to know is a constant. And the constant is simply the number that's by itself. So let's go ahead and take a look at a couple examples just to clarify these three definitions. Okay. So let's say we have the expression 3x plus 6. So in this example, x is our variable. The 3 is our coefficient because that's the number that's being multiplied by the variable. And finally, 6 would be our constant because that's the number that is by itself. Alright, now we're going to look at one more definition and then we'll head on to polynomials. The next important word to know is a term. It's a bit of a lengthy definition, so I'm actually going to type it out. Okay, so a term is a number, a variable, or a combination of both numbers and variables that are being multiplied together. An easy way to help you identify the terms in an expression is the fact that they are always separated by addition or subtraction. So if we were to look back at this example we had over here, 3x plus 6, notice that there is the plus symbol here. So the first term is 3x, and that's a combination of a number and a variable. And then our second term would be the plus 6, or positive 6. So in this expression, there are two terms. Oh, by the way, one thing I forgot to mention when we're talking about coefficients, if you're ever dealing with a variable like x that has no coefficient written in front of it, there actually is, and it is a 1, and it's just usually not written because it's, well, you could compare it to languages. If you could say I have one cat, or you could say I have a cat. So yeah, mathematicians usually don't write the 1 because it's not really necessary. 1 times x is the same thing as x. So just remember, anytime you're dealing with a variable that looks like it has no coefficient, there's actually an invisible 1 in front of it. So that's important to remember. Okay, so let's now define polynomial. Let's head down here. The word polynomial literally translates into many terms. The word, or the prefix poly means many, and nomial in this case means terms. So a polynomial is basically a math expression that contains many terms, although that can be a little bit misleading because technically a polynomial can also just have one term. Okay, and now we'll get into three different types of polynomials that you'll often encounter. The first is a monomial. The second one is a binomial. And the third polynomial is called a trinomial. And these are all specific types of polynomials. And as you might have guessed by looking at the prefixes of these words, mono meaning one, a monomial means it's a polynomial that only contains one term. A binomial, bi meaning two, means that it would have two terms. And finally, trinomial, tri meaning three, that would contain three terms. So I'll give you a quick example. So a monomial could be 3x squared. That's just one term. A binomial could be 4x plus 6, and a trinomial could be x plus x squared minus 4. So there's three terms in that one. And if you ever encounter polynomials that have more than three terms, they're just simply called polynomials. Okay, now we're nearly done our definitions, just a couple left. Next up is, let's see, degree of a term. And basically, the degree of a term is the value of the variable's exponent. So let's take a quick look at a couple examples. If we had, I can't really see that very well, 3x squared, the variable's exponent in this case is 2, so it would have a degree of 2. If we looked at the term, let's say 4x to the power of 10, well, in this case, our degree is 10, because that's the value of the variable's exponent. Now, two weird cases that are important here is when you're looking at x and there is no visible exponent. For example, 3x. And you might be wondering, well, there's nothing written here. What's the value of its exponent? And it's actually 1, because anything to the power of 1 is itself. For example, 10 to the power of 1 is just 10. So similarly, when you have x and you're wondering what's the coefficient, there's nothing written in front of it, there's actually an invisible 1 there. The same applies to the exponent. If there's no exponent for the variable, there actually is one, it's just an invisible 1. So, variable with no visible exponent actually has a degree of 1. And finally, the second weird case is if you're dealing with a term that has no variable. For example, 5. This actually does have a degree, and in this case, it has a degree of 0. It's a little weird of a reason why, but I'm going to try my best to explain. If you've gone through your powers and exponents unit, you would know that anything to the power of 0 is actually 1. So if we had any number, we'll call it x, and it was to the power of 0, no matter what x was equal to, if you raise it to the power of 0, you would actually get an answer of 1. So if we were able to multiply 5 times x to the power of 0, this is actually the same thing as 5 times 1, which is just 5. And so that's the reason anytime you have a number by itself or a constant with no variable, the degree is actually 0, because if you were to multiply it with a variable, the degree of that would have to be 0. So kind of weird. Hopefully, if that helps make sense of why. Okay, moving on to our next definition. Instead of degree of a term, it is degree of degree of a polynomial. And the degree of a polynomial is essentially the value of the biggest exponent. So for example, if we looked at this polynomial, 4x to the power of 6 plus 13x to the power of 10 plus 40, the degree of this entire polynomial would be 10 because that is the largest exponent we can see. Yeah. By the way, the proper way of writing a polynomial is going from the term with the largest degree down to the smallest. So you would, it'd be bad math grammar if you were to write a polynomial like 6 plus 2x plus 3x squared, because that's actually going from the smallest degree to the largest. The way that should be written would be to write the 3x squared term first, because that has the largest degree of 2, and then our 2x term, which has a degree of 1, and finally the plus 6, which would have a degree of 0. So that's actually the proper way of writing a polynomial. Whew. Okay, down to our final, last definition, and this one is like terms. And this, being able to combine like terms is actually what's going to be covered in the next video. And that's basically how you simplify a polynomial expression. So like terms have the same variable and exponent. Let's take a quick look at some examples so you can get a better idea of what I mean by that. Let's compare the term 4 to the term x squared. Now these ones, 4 and x squared, they definitely don't have the same variable. I mean, the term 4 itself doesn't even have a variable, and the other one is x squared. So these are not like terms. Let's take a look at 4x versus x squared. Now both of these terms do have variables. In fact, they're the same variable, x. However, the exponents are not the same. This term on the left has an exponent of 1, whereas this one has an exponent of 2. So again, these are not like terms. What about 4x squared versus x squared? Now this time, they both have the same variable and they have both the same exponent. So yes, these are like terms. One more quick example. If we compared 4x squared to 4y squared, you might think that they are like terms, but because they do have the same exponent, they both have an exponent of 2, but their variables are different. We've got an x and versus a y, so these are not like each other. Alright, that's it for this video. I hope it was helpful. I know there's a lot of definitions and terms to be aware of, so I hope this was helpful.